Good day, I'm Dr. T and welcome to my office. So today I'd like to talk about fatty acids. Fatty acids are going to be long carbon chains with an acid functional group, as the name would suggest. Typically these chains are not going to be branched, so there's simply going to be a straight chain, CH2s all the way down. They're typically only going to have the functional group of the acid, although some of them do have double bonds, so they'll have alkene functional groups. The ones that have alkene functional groups are going to be known as unsaturated fatty acids because in theory you could add more hydrogens to them. You could saturate them with hydrogens. And the ones without double bonds are known as saturated fatty acids because they are fully loaded with hydrogens. You can't add more hydrogens to them, at least without getting rid of the acid functional group. Fatty acids are also typically, but not always, going to be an even number of carbon. That's because most of them, especially in eukaryotes, are going to be derived from acetyl-CoA, which is adding 2 carbons at a time, and therefore you get an even number. For those fatty acids that are unsaturated, of course, not only does the length of the fatty acid matter, which typically speaking, we are talking, over a dozen carbons, very easily into, 24 carbons in length. So these are fairly large molecules, at least for, kind of individual non-polymer based molecules. Now, with the unsaturated fatty acids, of course, the location of the double bond is important. Typically, in normal UPAC naming, we would indicate the location of the double bond relative to the acid functional group. However, for both historical and practical reasons, for fatty acids, we indicate the location of the double bond based not on the acid functional group, but on the tail, or the CH3. That's at the opposite end of the fatty acid. This is an older style of naming acids that was common, kind of in the past. It's not used so much anymore. However, it is actually fairly useful in biochemistry by denoting the CH3 end because cells are very readily able to add and remove carbon groups from the acid end. Those oxygens give it a place for the enzymes to function and to work on the fatty acid, which is why fatty acids are readily biodegradable, whereas just straight hydrocarbons aren't. Well, because the cells are doing a lot of work on the acid end, that can readily change, but a lot of the key properties for that double bond are going to stay relatively similar. So it's useful to look at the double bond's location relative to the other end of the fatty acid. And to do this, we give this the omega nomenclature. So we'll say omega, which would be a lowercase Greek omega when we're writing it out, and then simply how many carbons away from the tail is the double bond. Typically, this is going to be things like 3 carbons away, so this would be omega-3. And I should also note that when we're indicating these, we usually only indicate the first one. So if you have 3 double bonds, then we would say, okay, it's an omega-3 if the first of the 3 is at the 3 carbons away from the tail position. We don't try and indicate the other ones because they typically follow a relatively straightforward and repeating pattern after that. Although in the naming of the fatty acids, you will see indicators to tell how many double bonds you have. Also, we could say, hey, monounsaturated, 1 double bond, polyunsaturated, many, etc. Omega-3s, as I've been talking about, these guys are going to have their first double bond 3 carbons away from the tail, and these are typically found in the thylakoid membranes of chloroplasts. As humans, we do not have the ability to make them. We have to acquire them from their diet, therefore they are essential fatty acids. Typically, though, you can't just go eat a bunch of green leafy stuff. That won't have enough omega-3 fatty acids in it, so those need to bioaccumulate. Say, eat some chicken that ate some bugs that ate some leaves, and that will bioaccumulate it enough for you to be able to acquire a reasonable amount in your diet. Typically, we speak of fish as a source of omega-3 fatty acids. That's because their food chain typically does involve things like algae that's rich in omega-3 fatty acids. The other essential fatty acid for us is the omega-6 fatty acid. This is going to be the first double bond 6 carbons from the end instead of 3. And in this case, we quite often see this in, say, seeds, etc. So this is going to also be a plant product, but from a different location of the plant. While this is an essential fatty acid, typically in a modern diet, we don't have to worry about this because it's rich in corn, and most of the animals that we eat, if we do choose to eat animals, they are going to be fed off of corn, and therefore they're going to bioaccumulate omega-6 fatty acids quite readily, to the point where we really do have a surplus, and the main consideration is for omega-3 fatty acids. And things like fish, which don't normally have a diet consisting of corn, is usually a good source. Tilapia is an interesting note in that those are mostly farm-raised, and those don't have much omega-3s because they typically eat predominantly corn. There are, of course, other omegas. You can have omega-9 and omega-12 fatty acids. Those typically we do have the ability to manufacture and therefore are not essential fatty acids for us. One last consideration when looking at fatty acids, all of those that have double bonds, those double bonds, if they are naturally occurring, are going to be in the cis configuration, whereas there are artificially created trans fats, or those that are in the trans configuration. These are less chemically reactive. You can, say, fry more French fries in a vat of trans fats before you have to throw it out. However, as would be suggested by them not naturally occurring, your cells don't handle them particularly well, and this can lead to negative health outcomes for the consumption of reasonably large amounts of these. For that reason, we've mostly started to phase out the use of trans fats, as while there are benefits to their use, those do not outweigh the costs for most individuals. So with that said, have a wonderful day, and I'll see you in later videos.